So this is Kerem Palabiyik from 4.1. We are making an industrial IoT platform. So our main focus is the companies which are making production. Why we are telling it's 4.1 is it's beyond Industry 4.0. So we are making end-to-end projects with our customers, offering from data collection to big data analytics, including predictive maintenance and all possible solutions, let's say. First of all, who we are. Actually, we are 4.1. We make industrial IoT projects. Our main focus is make it with zero human touch, so there will be no manipulated data. And our target is minimize the operational time and improve the quality. But the solution is really easy configured and all integrated to manufacturing environments. Of course, our solution is supported by Intel, let's say powered by Intel. Actually, lots of people are talking about Industry 4.0, but our main focus is big data, Internet of Things, and cloud computing. But of course, it's including cybersecurity, system integration, and all other stuff. But if we are talking about Industry 4.0, it should include IoT, cloud computing, and big data. You will see lots of companies which are talking about Industry 4.0 without cloud, without big data, or without Internet of Things. Basically, they offer Industry 3.0. I think everybody knows what's going on in Industry 1.0, 2.0, 3.0, and 4.0. But the main point that I want to show is the years of it. So you will see the speed, how it accelerates in years. So from 1 to 2, it was 100 years, and from 2nd to 3, it was 70 years. Now we are talking about Industry 4.0, and it's almost 45 years. According to, let's say, the agencies or research companies, Industry 5.0 will come in 15 years. There are lots of different mentality, what's going to happen in Industry 5.0, but what we see as a company is it will be a digital ecosystem. There will be flexible and integrated value chain networks. Process will be virtualized, and there will be virtualized customer interfaces. But the most important thing from our side is industry collaboration. So what do we say with industry collaboration is basically you have an engine that you use in your facility. When you make analytics, let's say you make a predictive maintenance with it, you collect or you make prediction over its own data. But there are lots of companies in the world which are using the same engine in the same or similar conditions. As you can imagine, more data works better algorithms. So what we are offering to our customers, if they allow us to use their data in our analytics, we offer them the algorithms that we created. So we create a collaboration platform for their machines. But also it's possible to open this data to their manufacturers, to their service companies, to their HR companies. There are lots of options to create a collaboration with this data. So how we do it is, first of all, we collect data. In IoT, maybe it's the biggest important part of a solution from end to end. But when we talk about industry, it's getting more difficult because we are talking about industrial conditions. We need to use IP-grade sensors or gateways. So, and it should be, of course, it should be working 7/24. So we collect data and push it to cloud from a secure gateway, let's say. With it, we create a big data platform. So with this platform, you can basically make descriptive analytics. So you can basically answer a question of what happened. The second option will be diagnostic and why did it happen? From our side, the most important part is the predictive analytics. What will happen? So when your machine will break down or when your engine will break down, we can tell lots of details about what's going to happen. The fourth part is the prescriptive analytics. So basically you answer a question, how can we make it happen? Third part is with this data, with this analytic, make an action. So you basically make real-time stream processing. So you basically catch anomalies and inform related people or related workers in the system. You can trigger events or alerts based on complex or dynamic criteria. For example, look, your engine is going to break down and you didn't make any maintenance action, so I'm shutting down this machine. So how can we do this is to interfere with local systems. So basically we can trigger a PLC, we can trigger a light or any other option, let's say. So when we talk about Industry 4.0, the biggest problem from the solution provider side is the vision of our customers. If you want to implement Industry 4.0 to your factory or a facility, you need to go step by step from our side. This is our methodology. So what we do is basically we start with vertical integration. So without making an integration, you can talk about augmented reality, or you cannot talk about predictive maintenance. You should start with vertical integration, so collecting data. The important part is collecting the real data, related data, and needed frequency. For example, if you want to make a prediction for an engine, you need to be able to get at least 3,000 samples in a second from that engine, if you are talking about vibration or temperature. The second part is, so we collected data, basically we start monitoring it. What we do is making condition monitoring. You can basically monitor temperature, vibration, humidity, energy, PLC, CNC parameters, alarms, or whatever you want to collect. Third part is big data process optimization. So with this data, you start making optimizations. You start with quality, the availability of the machine, the performance of the machine, performance of the worker. You go in deep with cycle time analysis. And after that, you start predictive maintenance. According to feedback from related machines and the customer's quality and maintenance system, we make basically a correlation between them and we predict when it's going to break down. Prescriptive analytics is, as I said, when you want to make a suggestion about your production, how can you increase quality or how can you improve cycle times? Augmented reality is giving all of this data to a mixed reality or augmented reality device. So basically all employees or all related people in the field can act according to this data in real time. The digital factory is making factory working with this artificial intelligence. So basically, you make your production plan according to feedback from your facility. You give orders to your suppliers accordingly. You organize your third-party logistics company accordingly. So it's all together working basically. So when we talk about, if we start with vertical integration, for Industry 4.0, the most important part is analytics at the edge. So if we are talking an IoT project and let's say our customer's facility is burning, but there is no internet connection and you cannot give them an alert or whatever is needed, so your platform will be useless. So what you need to do is you need to make a small cloud environment in the edge device. Actually, the devices that we are using is with Atom processors, but running analytic algorithms in it. So when it catches an anomaly or if it catches an alarm, it can basically send you an SMS or send you an email or trigger a PLC or trigger a siren. That's all possible. With these gateways, the important part is it should be IP class because we are talking about industrial environment. So the most critical part from our side is to make available this connection to the cloud as much as possible. So we use basically GSM lines which can resend data to the cloud over GPRS or 3G without a need from the customer side. Of course, a UPS connection to this device will make it working in bad situations. There are types of variables that you will need to connect, like RS485, 232, Zigbee, Bluetooth, Modbus connections. You need to collect data from sensors, from automation systems over TCP/IP, from robotics, energy analyzers, or relays. What we offer to customer is to use machines already installed interfaces. But if there is no interface at the machine, what we offer is to start to collecting data. Basically, we put relays related to operator's acts. So when he pushes a button from making the machine from automated to manual, for example, we put relays and we collect that, okay, this machine is started, this machine is stopped, this machine is working in manual work or automated work. So with this gateway, we push data to our cloud platform. The second part in our methodology is condition monitoring. What we basically see is we have a customer, they have two factories, and apparently seems that their two factories are working in good conditions. There are 74 active sensors, 16 users in the system, the weather forecast, and the alerts of today. And we also, as you can see here, we also catch the signal levels of all related sensors. That's to be sure if everything is connected to our platform. Some examples about condition monitoring is, as you see in the screen, it's an engine. You basically see vibration in two axes, temperature, engine parameters, active, reactive, frequency, and all other stuff, the voltage and ampere values in 3 phases. Another example, again, related with an engine, you can go really deep, like P-factor, voltage balance, active power, harmonics, or whatever you need. When you start seeing these conditions, you can define alarm levels accordingly. For example, if reactive power goes over 0.8, send me an SMS, send me an email. Not only engines, but for example, if we are talking about CNC machines, you can collect all needed data. Actually, in some brands, we are collecting around 3,500 parameters from each machine, and there is a huge data, let's say, that you can collect. And accordingly, you can make a prediction when to make maintenance to them. Actually, in this field, you will see how many hours you need to make a maintenance to that machine. How it works is basically, for example, when you define the frequency of the vibration or let's say in here it's bar, the condition of related sensors, you will see there's a delay in the characteristic of related machine. This means there's not a production error, but there can be deviations in the raw material. Another example is when the deviations from the tolerance show faulty or defective component in the process. Like as you see, the green ones is the normal period, but in some operations, it's going differently. So system is behaving differently according to their normal process. And in such situations, you will see lots of quality problems. With this condition monitoring, you can basically see what's happening in the real world of your facility. Actually, it's real time. So system can understand what's happening, if the product is okay or not with this vibration or the bar level or whatever sensor that we can use to create the characteristic of this machine. What you can also do is machine-human pairing, so you can basically know which worker is working with this machine. You can make polyvalence check, which means if related worker gets related training about that machine, if he can use it or not. You can make consecutive or scrap detection. It's with, again, anomaly detection. You can inform your quality department to make regular random quality checks. Or you can basically say, create the first product and then quality gives okay, and then you continue production. There are some applications in normal conditions, let's say. With big data process optimization, you can go in deep with related machine, work order, if machine is running now, what was the target, what the worker has done, if there's scrap, what's the performance of the machine, what's the availability of it, what's the quality ratio. You can see planned and unplanned maintenance. The critical part from our side is, for example, when we make integration to ERP systems, we can get data when the production order started and what's planned for it. But according to this performance data, system says, okay, look, you need to finish it at 10:44, but you will finish it 11:20 around. So basically with this data, you can organize your overtime planning. But also you can see all OE I think everybody knows overall equipment efficiency. You can basically see performance, quality, and availability of data. You can make cycle time analysis. This analysis is very critical from our customers because when they make a plan for a part production, let's say they put an engineer in front of the worker and they measure the time, but they don't know if they are making in with these parameters. So basically, as you see, this customer has organized around 3 minutes for normal cycle time, but the workers are working around 7 minutes. This means you are producing the related products more than 2 times slower, and your costs are double for the manpower part. Of course, it's affecting your OEE. With this analysis, you can basically increase or increase cycle time, or you can make necessary actions to downgrade the cycle times. There are lots of options. For example, production details in lines, shifts, performance, quality, availability, fail reasons, scrap reasons. You can create automated reports so management can see all production detail at the end of each shift with a basic report, so they can make necessary actions in real time. With big data process optimization, what you can do is SPC analysis, part per hour per operator analysis, line solidity, Pareto, automated shift reporting, overtime logging. So these are all possible options. Of course, our customers are asking lots of analytics about it. You can integrate human resources, you can integrate quality department, and each department will start using data and will need different actions in the future. The most important thing, or how can we say, the efficient part that you can see the ROI of the system is predictive maintenance. Basically, predictive maintenance is defining when your machine will break down. So the lifetime of the machine. You can see in this slide, there is a time delay. So red is faultless production process and green is production process after exchange of the control valves. So as you see, when you change the valves, your machine will work faster. And when this vibration level expands, you need to make maintenance. But to define or to get this graphics, basically you need to make sampling 3,000 or 4,000 in a second. What we do is put, if there is no sensors or if there is no interface to related machines, we put sensors to the machines and connect them to our platform. Sensors return data to our environments. Related people or maintenance departments basically monitors all data remotely. In parallel, our machine learning algorithms start learning about what's going to happen, and according to that, they give related predictions 2 times a day. In day 0, what we offer to our customer is to integrate anomaly detection, because For example, the same engine can behave differently in different facilities. So because of that, we start anomaly detection in day 0. After 30 days, we sit with the customer and check the data in last 30 days. And according to that data, we create alarm levels so our customers can be informed if something is happening. After 3 months, let's say 90 days, we start making predictions. So basically, to make prediction, actually we need around 3 months data from related machines. Of course, it depends on collaborative system that we go in detail in next slides. There are some other options. Actually, this is a fault detection. There's a misunderstood in lots of companies that which make analysis according to frequency of the vibration, and defects defines the problem in related engine, in which part of the engine is broken or it's going bad. Basically, this is not a prediction, it's a fault detection, because in usual systems, they tell you what's already happening in the system. With predictive maintenance, we inform them before. It depends on, of course, data, but we inform them 1 week or 1 month before that their machine or engine will break down. Of course, there are multiple ways or algorithms to make predictive maintenance, but when we are talking about supervised learning in machine learning, you need to get prediction, you need to get maintenance data from customers. One way is to integrate their system to collect maintenance reports, because which machine, when they started working on the machine, what was the fault type, what has happened, was it planned or not planned, and what's the status now. If you want to make predictive maintenance with supervised learning, let's say, you need to get their maintenance data, basically. Prescriptive Analytics is a little bit related with academic level, but also we have internal data science teams, and we have some partners, international partners, that with the collected data from related machines, we open data to related parties, and they work on this data to increase quality, increase efficiency, decreasing, let's say, energy, or decreasing the cycle time. After all of that, you can go in detail about augmented reality. So basically, when you see an engine or a machine, you can see in which parts there are sensors, if they are okay or not, how should they control it, and other stuff. But to go into augmented reality or mixed reality, as I said, you should go through a similar methodology. Digital factory is, let's say, connecting all related decision systems in the factory or in the company. You need to connect all machines. You need to see their performances. You need to see what's your workers doing, so you can basically say which part should be produced in which machine with which worker. After getting this data, you can organize your production, you can organize your supply chain, you can organize your predictive maintenance. So for that predictive maintenance, you can organize your spare parts. With this production data, you can organize your 3PL or third-party logistic companies. So it's all connected, and all decisions are running based on the feedback from artificial intelligence. Actually, you can manage it with all artificial intelligence, but basically customers are asking to see data, and according to they organize this synchronization. What's different from a traditional automation company from our side is we are an advanced analytics company. So we make artificial intelligence, we use chatbots, and we use machine learning for our system. There are supervised, unsupervised time series forecasting and anomaly detection algorithms. There are some of them you can see in the slide. And you can define the effect of vibration, temperature in axis. You can see original data, the trend, seasonality, and residuals. And it's not like a traditional automation system, as you can see. We create a big data platform for our customers, and we make analytics with this data. Just a brief infrastructure about our system. We are using AWS. Our codes are running on AWS. We collect data, we push it to Kinesis, and Kinesis push data to related parties. We use Spark Cluster in real-time stream processing. We use EMR in batch processing. This is the part where we use collaboration. EMR connects to S3, basically collects, for example, if you are talking about 90 watts engine, EMR collects from a switch all 90 kilowatt engine details for all customers. And according to that, it runs with related algorithms. Again, what's beyond Industry 4.0 is we make a collaborative platform. So when you have 1 or 10 engine, let's say, you create a graphic like this. If you have 100 engines, by the way, that should be in the same, let's say, model and the brand. You will see this graphic, but you cannot be sure about this gap. But when you use our system, you will definitely see that the characteristic of this machine is different. So this period can give you 3 hours, 3 weeks, or 3 months, which will decrease your maintenance period from 4 to 3 or from 4 to 2. This is related with more data runs better algorithms. Actually, it works with simple mentality. If our customers allows us to use data, we give them all related outputs to use with their system. What are we doing else for including different from our IoT platform is we make smart pit-to-light projects, smart fuel tank supply chain. For example, we have an automotive customer. They have around 12 tanks, and they give us the forecast in which type of engine they are going to produce. Is it working with diesel or other types? We check the forecasts, we check the weather condition. You should give an order to related company 5 days before. So our system makes it automated to give related orders to related customers. There are some references that we are talking, but basically this is what we do, and this is what we see as what's beyond Industry 4.0. So it will be a digital ecosystem. There will be value-added networks. There will be collaboration. So you will be able to define all related data in day zero, and you will see direct effects of the platforms. Thank you for watching. Have a nice day.